An inverse function is when you can take a function, compose it with itself, and you get x as the end result. So f of f inverse of x is by definition x. And I'm going to write in a darker marker so it'll show up on the camera. Now, I want to know the derivative of this. I want to know what is the derivative of the inverse of a function. So, taking this, I'm going to rewrite it as f of f inverse of x. And again, that's still equal to x. Now, if I take the derivative of this with respect to x, it's a chain rule. And the chain rule says we take the derivative of the outer part and multiply it by the derivative of the inner part. Well, that's what we don't know. We don't know what the derivative of f inverse of x is. So I'm going to say times d dx of f inverse of x. And then what's the derivative of x? 1. It's 1. Derivative of x is 1. So, the derivative with respect to x of f inverse of x is 1 over f prime of f inverse of x. That's how you take the derivative of the inverse of a function. Now, the main deal with inverse functions is dealing with the inverse trig function. So let's talk about the derivative of sine inverse. And I'm going to say sine inverse of u here. Well, I'm going to start off by this definition. I know that the sine of the sine inverse of u is u. Because again, I'm taking a function, I'm composing it with its inverse. That is the end result. Now, think about when you have an inverse function, what you're looking for is an angle. Typically, if you're taking, you're saying sine of an angle is, and it's the ratio. In this case, it would be the ratio of the opposite to the hypotenuse. But this is going to be the angle that has a ratio of a particular opposite to hypotenuse. So, let's take the derivative here. The derivative of sine inverse of x is going to be the cosine of sine inverse of x times the derivative of, u is the derivative of the sine inverse of u times. Now, what is the derivative of u? Well, it would be, if it was x, we'd just say it was 1x. But this is u, so we're going to say it's either du or u prime. I'm going to leave it as u prime because that's the notation we've looked at the majority of the time in here. So, the derivative of sine inverse of u is u prime over the cosine of the sine inverse of u. Well, there's a problem here. Because if you look up or Google what is the derivative of inverse sine of u, it's going to say that it's this. It's going to say it's 1 over the square root. It's going to say it's u prime over the square root of 1 minus u squared. Now, how are those two things the same thing? How would those two things be the same thing? Well,
Because when you can't you multiply the cosine and sine and
because this is not multiplication, this is saying the
Oh.
cosine of the sine inverse. But that has to do with this. Let's draw a triangle that has a sine of u. I'm going to let this be my angle theta. Now, how do we get a sine of u out of that? Well, the opposite over the hypotenuse, right? Okay. Now, what do we want to know from this? We've got the sine of u, but we need to know its cosine. Well, cosine is a ratio of what to what? Adjacent over hypotenuse. What's the problem here? We don't know the adjacent. And there's no way on earth that we can figure out the adjacent, is there? Of course there's a way we can. The Pythagorean theorem, yes. All right, so a squared plus u squared equals 1. So a squared is going to be 1 minus u squared, right? Now it's going to be you typically do the plus or minus square root, but this is a positive a value here, right? Because it's in the first quadrant. So we're going to say a is equal to the square root of 1 minus u squared. So the cosine of the sine inverse of u is the square root of 1 minus u squared over 1, right?
Yeah.
Which is just 1 minus the u squared. So that is how these two derivatives are the same thing. This here is what we're going to work with. Now, the derivative of cosine inverse of u is going to be the negative of the sine derivative of sine inverse of u. And the whole reason it is a negative, you start off with cosine of cosine inverse, the derivative of cosine is negative sine. So you get this negative with the sine, and that's the reason it's the negative of that. So let's start writing them out here. dx of the sine inverse of u is u prime over the square root of 1 minus u squared. The derivative with respect to x of cosine inverse of u is negative u prime over the square root of 1 minus u squared. Are we okay to keep going? Mm-hmm. All right. Let's look at tangent inverse. The derivative with respect to x of tangent inverse of u is what we want to solve for. So we know that the tangent of the tangent inverse of u, by definition, is u. And again, what is the derivative of the tangent of any angle? Of the angle.
Times the tangent squared.
Well, just times the derivative. In this case, it's of tangent inverse, which is what we're looking for. So all we can do is write d dx of the tangent inverse of u. And again, that's equal to u prime. So now the derivative with respect to x of the tangent inverse of u is u prime over the secant squared of the tangent inverse of u. And of course, again, if you look up the derivative of inverse tangent of an angle, you are not going to see it written like this. So let's figure out what it would be. Well, again, we want to draw a triangle that has a tangent of u. So how do I need to label what if my tangent is going to be u? Well, tangent is a ratio of what to what?
Sine over cosine.
Sine over cosine, but in terms of opposite over adjacent here. Okay, so tangent is going to be opposite over adjacent, so u is the same thing as u over 1. So opposite over adjacent. So this time when we solve the triangle out, we're going to be looking for the hypotenuse. So 1 plus u squared equals h squared. So h is going to be the square root of 1 plus u squared. Okay, so we've got our triangle set up. This triangle has a tangent of u. Or that angle, I should say. That angle has a tangent of u. So how do we determine the secant from that? Because we need the secant of this angle, right? So what is the secant the ratio of?
Cosine.
It's what?
Cosine.
It's 1 over cosine, right? And cosine is adjacent over hypotenuse, so what would secant be?
Oh, so would it be,
Hypotenuse over adjacent.
It'd be hypotenuse over adjacent here. Does that make sense? Okay, so we've got the hypotenuse over the adjacent, which would just be the square root of 1 plus u squared, right? Because it'd be over 1. But it's not just the secant, it's the secant squared, so let's square that. So what do we get as our end result here?
Which is 1 plus u squared.
1 plus u squared. So the derivative of tangent inverse of u is u prime over 1 plus u squared. And just like with cosine, cotangent's going to be the opposite of that, or the negative of that, I should say. And that is my result. So I want y'all on your own, and I'm going to put this on the next video, to figure out what the derivative of secant inverse is and set it up similar to what we did the last two problems.